Okay, so in class the other day, you guys learned how to do electron configurations. We talked about finding the total number of electrons based on the periodic table, and then using that to make orbital diagrams. That was the Hogg-Hilton, where you would start with 1s, put in your 2 electrons, then you'd go to 2s, put in your electrons, and then continue following those rules of the Hogg-Hilton depending on how many electrons you had. So let's say that we had 8 total. Let's say this was oxygen with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's what we had done on Friday. Nice and easy when you have 8 electrons. But when I give you one with 90 electrons, you're not going to be real happy with me because this is going to be incredibly difficult. So there is a shortcut. And the shortcut, of course, involves the all-powerful periodic table. So I'm going to try right now to draw a little periodic table. I can't hear you, so if you are laughing, that is perfectly acceptable. Okay? And now we're going to label the parts. You'll notice the periodic table is made of 2 towers, a part, kind of a bridge that connects them, and then that little thing on the bottom. So there are 4 sections here of my periodic table. Also remember that in order to make this work, in reality, when you see the periodic table, hydrogen is sitting right up here, and helium is sitting right over here. And they're both kind of by themselves. So in order for this to work, and we talked about this, I think, a little bit on Friday, we have to basically move helium all the way over here. Okay? He really does fit on this right side right there. He has so much in common with those noble gases. But for electron configuration purposes, you have to think of him as being in his own little square right here instead of over here. So I'm going to modify my periodic table a little bit. I'm going to erase those lines I just made, and I'm going to go ahead and put helium right over here, He. Okay, so 4 parts of my periodic table. There are, if you remember, 4 types of orbitals. We have s orbitals that are round, p that are bow ties, d that are clover leaves, f that are complicated. So we are going to label the periodic table with those 4 orbitals. This is my s tower. This is my p tower. Sometimes we say s block and p block. This is my d block or my d tower. This is my f. So with these parts of the periodic table labeled, this becomes your shortcut. Sorry, let me make this f a little bit more obvious for you. There he goes. Okay, so the way this shortcut works is in addition to these blocks, you'll notice on your real periodic table. In fact, as we're doing this, you might want to go ahead and label your periodic table. There are numbers over here on the side. Okay, you got a 1 right up there with those guys, then a 2, okay, then a 3, and of course the scale of mine is all screwy, 4, 5, 6, 7. Okay, these are all the different rows. So this is row number 1, this is row number 2, all the way across, row number 3, 4, 5, etc. So, for an electron configuration, you've probably heard me look at the periodic table and just be able to spit out the electron configuration. It's because you read it like a book. When you read a book, you start at the top left and you go across. Okay, then you will flip the page. Sorry. You start at the top left. English is my first language. It really is. You read across. Then you go to the next line. You read across. Then you go to the next line. Then you read across. That's how we read. You are going to do the same thing with this periodic table. Now, for simplicity's sake, I'm going to take the F block out of this drawing just so I can make it a little bigger. Again, you know I can't draw, so the scale is all messed up. But my S tower over here, okay, looks about like this. 4, that one will go all the way across. 5th row, 6th row, 7th row. Okay. And then over here, I actually have 6 different boxes. So I want you to think for a second. When we were doing full electron configurations, when we did an S, if an S orbital was full, it had 2 electrons in it. Well, what do you know? Look at this S block right here. It's 2 electrons wide. When we did a P, and a P was full. Remember, a P was 3 different rooms in the Hog Hilton. If we filled it up, how many electrons were in it? 6. Well, what do you know? Look over here. There's 6 going across in the P block. So think about it for a second. When I have my D, that's 5 rooms in my Hog Hilton. Okay, 1, 2, 3, 4, 5. Ooh, that's a mess. Okay, if I have my 5 rooms and they're all filled up, that gives me 10 electrons. So guess how many blocks there are in this middle section of the periodic table? That is correct. There are 10. Let's see if I can get them in here real quick without making a giant mess. There we go. So, to do the shorthand of the electron configuration, again, we're going to assume that the periodic table is made correctly. So we know that row 1 doesn't actually go all the way across. There's really just helium, which we're going to pull right over here, okay, instead of having him here. So, as we're looking at the periodic table, we're going to read it like a book. So let's say I want to find the electron configuration of this element right here. And if you look at your periodic table, that happens to be phosphorus. Instead of drawing lines, I'm going to read the book. This first square is row 1. It is block S. Sorry, I'm having iPad troubles. And it's the first one that I get to. So that's 1s1. Assuming helium is here, he's in the first row. He's in the S block. He's the second one I get to. When I continue across, there are no other blocks. So now I'll come down here. This is the second row. It is the S tower, and it's the first block. Second row, S tower, second block. This is still the second row, but this is the P block, and it's the first one I'm getting to in the P block. So this is 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. Every square can be labeled based on where it is. This is 3P1, 3P2, okay? So to do the shorthand configuration, I'm just going to say the end of whatever section I'm going to. So if I say 1s2, that means I've gone through both of those. Now I'm going to keep reading my book. I have to go through 2s2. That means I've gone through both 2s1 and 2s2. Now I'm going to go through this set, 2p6. Now I'm going to go through this set, 3s2. Now I'm going to stop at my orange dot. So I am stopping at 3p3. That's how you do electron configurations a much, much simpler way. Okay? Now, when you get down here to the D block likes to be difficult. So let's say I was going to this square right here. I'm going to do the same thing. 1s2, okay, in fact, I'll use my yellow line again. 1s2, 2s2, 2p6, 3s2, 3p6. So if I'm doing that yellow dot, 1s2, 2s2, in fact, let me slide this up a little bit if my iPad will behave. There we go. I went through 1s2, 2s2, 2p6, 3s2, 3p6. Now as I keep going, that's row 4, so that's 4s2. And now I'm going to go over to my dot. Here's the problem. The D block is difficult, okay? Whenever you do the D block, you have to take the energy level -1. So this is 4s right here, 4s. This is not 4D, this is 3D. It's -1, okay? This is 5s, therefore this is 4D. This is 6s, so this is 5D. My D section is always going to be 1 less on the energy level. And then we go back to where we should have been with the energy level on the P. The P is exactly like you think it should be. So when we go through 4s2, to get over to my yellow dot, I'm going to go through 3D 1, 2, 3, 4, 5, 6, 7, and it's 3D7. The F block, if we were to add him down at the bottom, is really interesting because the F block, there are 14 of those squares, I ain't drawing them all, the F block is -2. And the biggest thing to remember about the F block is it actually fits right up in there. In reality, your periodic table should have an S block, an F, a D, and a P. That's what the periodic table should look like. But that thing is huge. Okay, in fact, it's too big. So we don't draw it like that. But we do electron configurations like that. So as you're doing electron configurations, you go through your S's, okay, then you go through S, then D, then P, S, then D, then P. But when you get down here to row 6, you go S, and then F, and then D, and then P. So if we're in 6S, this would be 4F, 5D, and then we'd be back up to 6P. It's the only way this gets difficult. But again, it's just like reading a book. You just have to remember that F fits into here and that the F and the D energy levels are smaller. Okay? The next lesson we'll talk about a little shorter way to do this.